We all make silly mistakes, and silly mistakes cost you the marks. In this video, I'm going to show you a few mistakes. I'm going to see if you can spot it. For example, the mistake of using this red pen, which is clearly run out. For each question, I'd like you to try and identify the mistake and, where possible, correct it. There will be one question that is impossible to solve, but I say that at the time. In this question, we're given y, we're given a function, and we have to find the derivative. That seems easy enough. So the derivative that we're looking for is dy dx, and we're trying to find the derivative of the y that's given. I'll just simplify the y first. So if you remember, the power of a half is represented by a square root, and that's plus 1. And then x squared is like this. We probably should simplify this. So x to the half divided by x squared. And then we can add the 1 on the end. Which kind of cancel, and there's 1 left over. And then using our laws of indices, 1/2 take away 2 is minus 1.5, or minus 3 over 2. And then plus 1. That's the derivative done. In this question, we've got a triangle M&S, and it's got the side lengths 0.1, 0.2, 0.3. We're looking for the size of the smallest angle. So if I draw a quick diagram, M&S, like this, and then it doesn't really matter where the lengths are. I'm going to draw them like this. The smallest side is going to be opposite the smallest angle. So the angle that we want, I'll call it alpha, can go in here. 3 sides, 1 angle, this is the cosine rule. Let me just quickly write that out. So the A and the A are going to be the two opposite sides. So the A is going to be 0.1 squared. B squared is going to be 0.2 squared. C squared is going to be 0.3 squared. And then the A, the big A, the capital A, is going to be the alpha, the angle that we're looking for. But we can just work these out. That's 0.01, 0.04, and 0.09. And then 0.2 times 0.3 is 0.06, which times by 2 is 0.12. Now I can add together the two decimals on the right-hand side, like this. And then I can subtract the 0.13 from both sides, like this. And then I can add 0.12 onto both sides. So I'll get 0 is cos alpha. And then I can do the inverse. Cos minus 1 of 0, which is 90 degrees. So it's a right angle triangle. Oh, this question again. So it's the same function. I'm going to differentiate it. So I think I should simplify it again. So x to the power of a half plus 1 over x squared. And to simplify it, I'm going to use the laws of exponents, so a half minus the 2, 3 over 2, but with a minus. And then plus 1 over x squared, separating out the fractions. Now I can differentiate it, because there's bringing down the power, and then minusing 1 from the power, so power minus 5 over 2. And then this x squared, bring down the power to 2, and take 1 off the power, so x to the power of 1, or just 2x. Okay, log question now. So when I see log, oh, it's got no base of the log. So I know that means base 10, really. So I'm going to write base 10 to make it easier. I know to get rid of a log, I'm going to do everything 10 to the power of the left-hand side and 10 to the power of the right-hand side. I'm pretty good with my laws of log, so I know that the 10 and the log 10 are going to cancel out. So half of x squared minus 9 is left, and then 10 to the 1 is just 10. But times both sides by 2. And then add 9. And then square root, we're done. In the similar looking question, it's the same triangle, so I'm going to draw it out in the same way. I'm just going to speed through the working from before, as I'll use the cosine rule again. So I'm going to put the cosine rule in. I'm going to make A 0.1, B 0.2, and C 0.3. And I'm going to square each of them to get 0.01, 0.04, and 0.09. And I'm going to try and simplify the decimals. So these two add together to get 0.13, and then minus 0.12, so that's going to be 0.01 on the right-hand side. And then I can divide by 0.11 to get 1 is equal to cos alpha. So alpha is going to be the inverse cos of 1, which should be 0 degrees. We're looking for a coefficient this time, specifically the coefficient of x to the power of 4 and the expansion of 3x minus 7 to the power of 7. I'm going to use this 7 choose 4 function because it's the x to the power of 4. And I'm going to make 3x to the power of 4 to get my coefficient in the same matching up. Then I can do minus 7, and because the power is 7 and the choose bit is 4, I'm going to make the power 3. Seems pretty straightforward, I'll just put it in. So minus 36,015, which seems good. In this log question, what I'm going to attempt to do this time is I'm first going to times both sides of the equation by 2 and see where that gets me. With times by 2, I'm going to get the log is equal to 2. And then I'm going to do 10 to the power of both sides, like this. So 10 and log will cancel out. So x squared minus 9 should be equal to 10 squared, or 100. So x squared is 109. So x is plus or minus root 109. But of course, we can't have a log of a negative, so we'll rub out the solution. So the only solution is root 109. This question, I'm looking to solve some kind of equation. For this one, I'm going to divide the left by 2 root x. So we're going to get left with 3 over 2 because the roots will cancel out. And then x plus 1, and then only 1 on the right because we've divided by it. If we now take away 1 from both sides, and maybe add x plus 1 to both sides, we'll get this. And then simple as that, x is minus half. In this expansion, I'm going to write down the choose function. So 7 choose should be choose 4 because it's x to the power of 4. Then I'm going to do 3x to the power of the same power to the power of 4. And I'm going to do minus 7 to the power of 7 minus 4, which is 3. I'm going to try not to forget the brackets. And then I'm just going to put this in the calculator. So 7 choose 9. And then I'm not going to put x in, I'm just going to put 3 to the power of 4 times minus 7. Oh, I cannot make a bracket. Minus 7 to the power of 3. Okay, there goes an error. So that matches up to what it says on the piece of paper. I'll try again. Okay, still get an error. So I'll just maybe get rid of this first term. And then, yeah, this seems about right. We're solving this one again. This time, I'm going to expand the bracket first. So we're going to have minus x, and we're going to have plus 1. And the right-hand side is going to stay the same. This time I'll subtract 2 root x from both sides. And I'll try and solve this. And then I'll do a little bit of a rearranging. And I'll rearrange again to get root x on its own. Because if I square both sides now, then I'll get rid of the root. So x squared is x squared, and 1 squared is 1. So we get this, and then I can rearrange it into a quadratic like this, which I can therefore use the calculator to find the solution. Or, old school quadratic formula, you do you. And we get 1 plus or minus root 5 over 2. Okay, in this question, it looks like there is a quadratic and it's got repeated roots. I can tell you that this doesn't have a real solution, so don't try and solve this one without making a mistake. B squared minus 4ac is equal to 0. That's because it's a repeated root. So I'm going to take b, I'm going to square it, 4, and then a is 2p, and c is 3. It should be equal to 0. If I square that bracket, I'm going to get p squared plus 6p plus 9. And then 4 times 3 is 12 times 2 is 24. If I expand this out, I get 2p squared plus 12p plus 18 minus 24p. And then I can divide by 2, might as well. And then those p terms, they go together. I get minus 6p. That doesn't count as a mistake, that plus. And then this factorizes, and we get p equals 3. What a nice solution, which you can just about see at the bottom. This derivative again. I know this well. So x to the half is going to represent the square root. And if I want the derivative, I'm going to differentiate, bring down the power. So we get half x to the minus half. The 1 is a constant, so differentiate is going to disappear. And then bring down the power, we get 2x to the power of 1, or 2x in the denominator. To simplify this, half over 2 is a quarter. And then minus 3 over 2 minus 1 is minus 5 over 2. Did you get all the mistakes?